All right, so we're in Algebra 1. Today's date is Friday, January 24th, 2020. So 124. Our objective for today is to do what? Kira.
Memorize square roots of squares and the cube roots of cubes. Find square roots of decimals and fractions.
Yes, and if you've ever watched Incredibles 2, it's decimals, not decimals. Yeah, that list needs to be memorized, and I pointed out that in terms of Khan Academy being quizzed and tested, they'll only go up to 144, but I think it's a really good idea to memorize the rest of these. Even down to 25 is kind of helpful in future life, in terms of your math career at least. And in terms of the quiz on cube roots, I will be quizzing you even down to 1,728. What is the cube root of that? You should know. Oh yeah, that's 12. So eventually you will slowly memorize them. I think that up to here is pretty easy, and those are the ones that you use most often. In terms of the unit test, it will go down further, but then after Algebra 1, when you hit geometry, I'm only going to be doing these ones over and over again. Question, Kira?
What do you use these for?
You use them to solve problems, like in calculus, you'll have random powers. If I take the integral and I eventually come out with something like 216 to the power of 1/3, and you're like, okay, I can convert that to the cube root of 216, and they say, oh, it needs to be in simplest form. Your answers are A, B, C, and they have, I don't know, it's 5, 6, and 7. You have to be able to say, oh, 216 to the power of 1/3, that's B.
So you just need it like for high school?
High school, college math, it's for your math career in general. So once you stop taking math, then you can probably stop using these. Does anyone know about the doubling of the cube problem from the Oracle Delphi? Never heard of that? All right, let's go on a brief tangent here. So I don't know the story exactly. Maybe I should look this up. But whenever I talk about cubes, I automatically think of that story. So they had the Greeks, or I don't even know if the Greeks, I'm going to get all this story wrong, and it's on video too, so I'm sorry if this is wrong, but there was a cube back in the day, and it was an impressive cube made out of something precious like, I don't know, marble or something, and it was kind of big, and they talked to this Oracle of Delphi, and she said, oh, if you want to please your gods, you need to double the volume of the cube. And then they're like, okay, let's just make the cube twice as big, right? So how do you, if you have a cube that's, I don't know, 1 by 1 by 1, nice, the easiest possible cube, they had one that was slightly harder, how would you double the volume of the cube? Well, if I have a cube that's just 2 of those cubes, right? Cube on top, cube on the bottom, it's no longer a cube because the cube needs to be the same dimension by the same dimension by the same dimension. So can you use only a ruler and compass? And of course, we're not in geometry yet, but can you use anything without using a calculator to double the volume of the cube? And if you play with this problem, you'll realize it's really hard to do. So your riddle is, how would you double the volume of a cube that's 1 by 1 by 1? How do you get a volume of 2? What would be the side lengths if the volume is 2? What by what by what is equal to 2? And the answer is the cube root of 2, which is, if I come on my calculator, 2 to the power of 1 divided by 3. Oh, the dimensions need to be 1.25992104999 all the way out to infinity. And there is a kind of pattern, but it's non-terminating. So there's my tangent. Tangent ended. Coming back here to talking about parts of a radical. So whenever I talk about a radical, this is what I mean when I say index. 4 is the index. This symbol right here, if I can circle just that symbol, that is called the radical symbol. Radical, man. Radical symbol. The thing on the inside is called a radicand. And all together, the whole thing is called just a radical. So it's a little bit more formal than saying a square root, because it might be a 4th root, it might be an 8th root. This one is a 4th root because it has an index of 4. a square root is an imprecise, well, I guess it's a too precise term. If I ever see the radical symbol and I have an index of 5 or 8, I can still call that thing a radical. So you won't be incorrect by saying that it's a radical. So all of these up here are radicals. That's a radical, that's a radical, that's a radical. But notice up here that there's no index. If you don't have an index, assume that's 2. So we'll say by default, come over here for the notes. By default, the index is 2, unless you state otherwise. So up here I stated, oh no, the index is 3. That means I'm talking about the cube root. Well, if the index is 2, that's called the square root, as you have seen over and over again. That's called the square root. And then these to the power of 3 are called cube roots. To the power of 4 are 4th roots, 5th roots, 6th roots, all the way up 10th roots. You can keep going on and on and on. Are there any questions about how to read these radicals? Okay. So another way of asking what a root is even talking about. So if I have the same thing, the 4th root of 16, it's actually asking a question. And here is the question that it's asking. What number multiplies by itself and then the index number of times, so 4 times. What number multiplied by itself 4 times? So if my number is, I chose 2. 2 times 2 times 2 times 2 is this answer of 16. So I ask myself, okay, could the number be 1? 1 times 1 times 1 times 1? Oh no, that's 1. Could it be 2? 2 times 2 times 2 times 2? Well, 2 times 2 is 4. Another 2 times 2 is 4. 4 times 4 is 16. Oh, the answer here is 16. The answer is 2. The 4th root of 16 is 2 because 2 multiplied by itself 4 times. 2 times 2 times 2 times 2. If I multiply by itself 4 times, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Oh, the 4th root of 16 is 2 because 2 times itself 4 times. So whenever I'm asking about cubes, another way of thinking about them is what times what times what 3 times, because I have an index of 3, will equal 12. And 12 times 12, 144. 144 times 12 again is 1,728. All right, so let's actually practice doing what you're going to be asked for tonight. You'll have 3 assignments, which sounds scary. One of the assignments is, what is the square root of 64? And you'll be like, 8. Okay, nice and easy. The other assignment will be, what is the cube root of 125? You'll say 5. Done. So those are the first 2 assignments. And the third assignment is doing the second part of this objective. What is the square root of a decimal and the square root of a fraction? And that's what I'm helping you with right now. All right, so the third assignment, what is the square root of 16 over 289? And the answer is, it's the square root of 16 over the square root of 289.
Which is?
And then I'll do another step in a second. I'll call him Eamon, sure. Eamon, what is that?
That would be 4/17.
4/17. Done.
What's so Mr. Sinal?
Yes, Emma.
Why would you have to write it twice if it's already written in a square root?
Yeah, so I have one square root that is covering the entire fraction, and then I turn it into 2 square roots, one in the numerator, one in the denominator. This is using your rules of exponents. Do you guys remember the rule of exponents that states this? If I have, I don't know, let's say 9 over 8. Oh, that's a horrible 8. And I say all that is to the power of 2, that's equal to 9 to the power of 2 over 8 to the power of 2. It's the same thing. If I have only one square, I apply it to the numerator and denominator. If I only have one square root, I apply it to the numerator and the denominator. Of course, you can skip that step because you know that step now, and you can just say, oh, immediately, oh yeah, 4/17. So we can skip that step for this next example too. Is there a quiet raised hand that can tell me both the numerator and the denominator for example 2? Go back and look at your table and hopefully start memorizing these. Who still has their card? Jade, do you have your card? Yeah, go for it, Jade.
19 and 13.
19 over 13. Yep, done. Nice and easy.
Why don't you have to do the other thing again?
Why don't I have to do this intermediate step right here?
Is it just something?
You could, to show your work, you could, but you don't have to. I assume that everyone kind of understands I'm really taking the square root of the numerator and the square root of the denominator, and you're okay. All right, so now we're moving on to example number 3. Decimals. I always have to check myself because I've watched Incredibles 2 so many times. I really want to say decimals.
Yes.
So the square root of 2.819, that seems like a random decimal. Wait a sec. 289, that sounds familiar. 289 is right there. That's the square root of just normal 289 is 17. So is there a quiet raised hand who wants to take a guess at the decimal? Who has their card? Oh, Asha has her card raised.
Well, maybe so 289. If the decimal's at the bottom, we would move the decimal 2 times. So would it be 0.17?
0.17 like that?
Yeah.
You're really, really close. So if I multiply 0.17 times itself, you can check your work. 0.17 times 0.17. I know that the number is going to be 289. I moved it 1, 2, 3, 4. So 1, 2, 3, 4. And the answer is 0.0289, which is close. It's just the decimal has moved way too far now. So how would you fix that, Esha?
Well, so we need it to be 2 spaces. So we need the
So whenever we multiply decimals, we count the total number here, and that's what the answer is going to be. So if the answer is 1, 2, then I have to take half of that for both of these.
So would it be 1.7?
It is indeed 1.7. So come back here and say this is 1.7. And you can check your work too. So you can say 1.7 times 1.7, and you can say, oh yeah, that's obviously 289 because I know my perfect squares, and I move the decimal 1, 2, 1, 2, 2.89. There it is. There is another way of looking at this that I will show once and then never again unless you really like it, which is this. And Khan Academy doesn't even show it this way. They just say, notice how it's similar to 17. You just move the decimal place once. But 2.89 is the same thing as 289 divided by 100. Whenever you divide by 100 or divide by anything that is a 10 to some power, the number of zeros talks about how many times I move the decimal place. I move the decimal place back 1, 2. And if I'm taking the square root of 2.81 or 2.89, I'm taking the square root of each of these. And now it's saying, what is the square root of 289? Well, that's 17. 17. What's the square root of 100? 10. And then I move the decimal place 1 back because there is 1 0, and this is equal to 1.7. So there's 2 ways of analyzing this, one with a fraction, one with decimals. Choose whichever one you would like. In general, though, Khan Academy is pretty easy. They're only going to make you move it 1 time. I don't think I've ever seen it move twice yet. So, let's try another one. Example number 4, 0.36. And I'm going to take the square root of that. That sounds very familiar. 0.36 sounds a lot like 36. Larissa?
So it would be 0.6.
0.6, done. And you can check your work again. I could say, come out here, 0.6 times 0.6 is 36, and I move the decimal 1, 2, 1, 2, 0.36 is our answer. All right, example 5, do on your own. Check with the neighbor, not with Mr. Sindel. Check with the neighbor. If you both get it correct, I assume you know what you're doing, and you may move on to Khan Academy. All right, good luck, guys.